So today this class will be an introduction, and we will start with like this short presentation so that we can have a course overview and have the basic ideas so that all of us will be on the same page. So in this course, first of all, we will be starting with an introduction, which is this class on the basics on the basic ideas that we'll be using in this course, as well as how we will navigate SolidWorks and use SolidWorks. Then in the coming classes, we'll be talking about how we can create 3D models in SolidWorks from 2D technical drawings or engineering drawings. And so this will be the format of the course, where we'll be having some 2D drawings of some parts, and we will be modeling those parts in SolidWorks. After that, we will be trying to do the opposite, where we will be having a 3D model of a part, and we will be creating a 2D drawings for that part so that we can convey or give all the information needed about that part in the 2D drawings. After that, in around the middle of the course period, we will be talking about some customization to SolidWorks to improve the workflow and productivity when you are using SolidWorks, like creating templates so that a lot of like the commands that are usually used or like the settings that are used are already opened in SolidWorks. And we'll be talking about some tips to improve your workflow and productivity in SolidWorks. After that, we will be talking about assemblies, since most engineering products are not a single part or a single piece, but they are an assembly or a combination of different parts. And so in that period of the course, we'll be learning how we can create different assemblies from parts that we created beforehand, and how we can perform some analysis, or like we can see how how the different parts move in the assembly. And finally, at the last class, we will be talking about the basics of rendering and animations in SolidWorks so that we can have a basic idea of how the different mechanisms in, for example, an assembly works. So this is what we'll be doing in the first period of the class. We'll be focusing on how we can create those 3D models that we can see on the right side from the 2D drawings that we are seeing from the left. And then we'll be focusing on doing the opposite, where we'll be creating us ourselves those 2D drawings from the parts that we are having. However, before we start using SolidWorks, we need to know what is SolidWorks and why we are using it. So SolidWorks is a CAD software, which simply stands for computer-aided design software. And so, as the name suggests, it is a software that simply helps the designer create designs that are effective in communicating the idea the designer wants to create. And so SolidWorks is one of many of those CAD softwares. There are other alternatives to SolidWorks, as we can see here. SolidWorks is one of them. We have AutoCAD, CATIA, Inventor, or Fusion 360. Every one of those different software essentially do the same thing, which is help the designer create 3D models. However, each software adds extra features to simplify some specific tasks. For example, CATIA is more suitable for surface modeling, for example, in the automotive industry, or Fusion 360 is more suitable for beginners, since it is, first of all, free of costs, and so it does not require investing, and it has also a student version which helps on like starting with the with 3D modeling in general. And so another thing that we need to be careful about is the function of CAD software. It's true that CAD software have a lot of features that are added to it, but it has one main task, and this is what we will be trying to improve in this course, which is to help communicate designs. Because any design or any product that is created always starts as an idea, and this idea needs to be communicated between different groups of people. So we have the designer that creates gets the idea of the part, and then this part should be manufactured or created. And to do that, we need to know all the different features within the part so that it can be manufacturing with different technologies. And to do that, we use 2D technical drawings or engineering drawings. So this is an example of a part that is taken from an assembly that we'll be seeing in the next slide. So as you can see, what a technical drawing or an engineering drawing does is that it shows different views of the part that we want to create, and it gives all the dimensions of the features in that part, which is an important part. Because if any of the dimensions are not specified, then the part may not be manufactured in a way that is functional. And so we need to be able to read those 2D drawings to be able to create 3D parts. Because in the field of engineering, those drawings are like writings in English. This is how engineers communicate the different designs of different parts, and with this, they develop different products. And so here we can see a 2D drawing of an assembly. So here we have a part, and in the 2D drawings of a part, we have all the dimensions of the different features. And in an assembly, we have the different parts that create the assembly. They are labeled, and also a basic idea of how they will be assembled is shown in this drawing. Also, we have something, a table at the bottom left corner, which we call the bill of the materials or bonds, which we'll be seeing later at the end of the course when we are talking about assemblies. And so 2D drawings can have two functions. Firstly, specify the dimensions of and features of a part, or specify the different parts in an assembly. And in order to specify the 2D dimensions of a part, we need to know something about the orthogonal views and different views about that part. So basically, we have most of the time orthogonal views are used to describe a part, or you can think of them as perpendicular views, which is the same thing as orthogonal. So if, for example, we have this part, if you want to describe it in a 2D paper, then we need to somehow convey all or describe all the features in that part on a 2D paper. The most common way is that to simply go and see it from different views. So first of all, for normally what happens is that we use the front view, side view, and top view as the main orthogonal views. So if we move our perspective to where this arrow is pointing, we could call this face, for example, or this direction, the front view. And if we simply draw what we can see from this view, then we can get something like this. This is one of the orthogonal views of this part, which is the front view. Another thing is that we can go to another direction. Here we can call it the right side view. We do the same thing. We draw what we see. So in the front view, we can see this line as a simple rectangle, the holes, the fillet, etc. And finally, we can do the same thing for the top view. So normally, in most of the times and in the cases, those three views are used. However, in some cases, there are some auxiliary views or like additional views that give extra information when the part is more complex. And also in some cases, there is also no need to use those three views, namely the front view that we can see in the middle, the right side view, which is to the right of it, and the top view, which is at the top of it. And as, for example, in communicating, if we can give all the information about a part in less number of views, it will be better since it will reduce the complexity of the reading the 2D drawings. However, there is one problem with what we are doing right now, which is that a lot of the features, such as those holes, are not visible in all views. And in order to do that, what we do is that we create drawings with solid lines or like solid lines that describe the features or like the edges that are directly visible. Like we can see in the front view, for example, the edge of the circular hole. However, if, for example, you have, like in this case, the horizontal hole, in the front view, it is not visible as we can see here. However, what we do to show that there is a feature in here is that we show it with dashed lines, which is lines that we call as hidden lines. Those lines simply tell us that there is a feature in there that is not directly visible. And so those are like some specific and some like examples of what are the different parts of 2D drawings. And as we go through the course and we see different drawings of different parts, we will be describing the different features in the 2D drawings that are used to describe those features in the parts so that we can model them. But this is the basic idea of the orthogonal views. And with this, we will be going to SolidWorks to see how it works. However, before that, there are like some resources that you could use for extra information if you want with the course or after the course is done, that gives you extra information related to SolidWorks. And in one of those, it gives you information related to Fusion 360. And as I said before, both of them are CAD software. And so even though they are different, they basically perform the same function. The different thing is that they would have a different name for the commands and a different placement for those commands. However, both software, for example, SolidWorks and Fusion 360, would have a command that would allow you to convert a 2D sketch and extrude it so that it will be a 3D model or a 3D part, as we will see in SolidWorks right now. So first of all is Titans of CNC, which is a YouTube channel, and it also has a website. This mainly focuses on manufacturing. And so as part of manufacturing and machining, we have 3D CAD software so that we can have a model of our part so that we can manufacture it or create it. And so with this, it focuses more on like CAD software and creating models that we can manufacture them in terms of CNC machining. Then there is Less Boring Lectures, again, a YouTube channel which has a playlist that is dedicated for SolidWorks and CAD software, which again describes the basics of SolidWorks, and it gives more examples and details of different features in SolidWorks that is given briefly and so concise. The third YouTube channel and last YouTube channel here is This Paul McWhorter, which has a playlist that talks about 3D printing and Fusion 360. As I said, you can watch this even if you don't have Fusion 360 or if you are planning to use SolidWorks, since the concepts described can be used in both software. And in this playlist, it focuses more on 3D printing. And so like at the same time, we'll be learning CAD software and principles used in 3D modeling, as well as keeping a mindset of creating those parts in 3D printers. Because as different to the Titans of CNC where they use CNC machining, CNC machining is like, it starts with a block or like a material and it cuts the materials, while 3D printer starts with nothing and creates the part. And so there is like different mindsets that is used to make sure that the part you are creating can be manufactured with what you are using. Finally, if you want to get into more details, we have a book that's called Technical Drawing with Engineering Graphics, which focuses in more details with the different parts of engineering drawings and modeling and technical drawings. It focuses more on like the different standards used, since there are different standards, and what we will be using here is like the ANSI standard. And it also describes the different, you can say, the rules that are used in 2D drawings so that the information about the part can be described in as easy and straightforward way as possible, so that there will be no confusion when people are communicating their designs with 2D drawings to create the 3D parts. And so with this, now we'll be going and seeing launching SolidWorks to see how it works and what we'll be seeing. So here, the first thing when you launch SolidWorks is this page is what you will be seeing. So we have here the welcome screen of SolidWorks, which will give you like the previous parts, the recent documents or previous parts that you created. From here, we can go directly. We have three different choices. The parts, which will be starting in the first period of the course. Then we will be focusing on drawings. Finally, we'll be focusing on assemblies. So you could simply click on parts. And from here, you will be having the basic and default SolidWorks user interface. However, if for some reason you click somewhere else, what will happen is that menu will disappear and you'll be left with this menu, with this blank page. Again, with this, you can also get to a new part or open a recent part by simply going to the top left corner and clicking on File and then New, which gives you this menu again to choose if you want to create a part, an assembly, or a drawing. And maybe in your case, you would have something like this, and simply you can toggle between the two views of the basic and advanced, so that here we'll be seeing how we will be creating different templates at the end of the course. So hopefully by the end of the course, you will no more need to use this beginner welcome screen, but you will be using the advanced view for creating different parts. So we can go with part, okay, and we can go back again to the default interface of SolidWorks. And so to describe the different navigation parts in SolidWorks, it will be useful to have a part, since in space we have nothing, and so we cannot have a good idea of what is happening in our main window. So we can go again to File, Open, and we can open one of the parts that we have. So here, later in this course, we'll be seeing how we can create those parts, but right now we can start from the top part of the screen, and we can see we have at the top our menu view. Normally, it would be hidden like this. We could click on the small triangle or hover our mouse, and then it will open the menu. We could click on the pen so that it will stay on there. And here we'll be doing something that you can do to help you launch SolidWorks faster, because as I said, SolidWorks gives you an extra features which are called add-ins to help simplify some specific processes. So if you go, for example, to tools, and if you go down to add-ins, we could have different add-ins or toolboxes that gives you extra or additional features. However, what we want to do in here is that if you have any checked add-ins in here, it will be better to uncheck it from the startup box, since in this course we will not be using them. And if you include all of the add-ins, it will increase the time SolidWorks needs to open. And so it will be better to simply uncheck them in startup. And if at any time when you are using SolidWorks, you want to use any add-in or toolbox, you could simply check it so that you will activate it in that session without needing to wait for long time when you are launching SolidWorks. So again, unchecking the add-ins since you will not be using them, and checking the boxes for the startup so that they will not be activated when SolidWorks launches, and we can click OK to start our session. So at the top here, we can see different tabs, and every tab gives its own commands for specific context. So we have here in the first one, the features, which we'll be seeing in the next classes. We also have a tab for sketch, which helps us create 2D sketches. And again, as we will see later in the course, all 3D models start as a 2D sketch, and then it gets extruded or revolved to a 3D model. And if you, for example, click the right mouse click on any of the tabs, or in what we call this part as the command manager, you will have a menu that shows the different tabs. So here you can see that I have only 5 tabs, but SolidWorks has other tabs, and as a default, you might have more than those tabs activated. However, if all those tabs are activated, it will clutter the area above you, and some of those tabs are not always used, depending on what you are doing and the purpose that you are using SolidWorks for. And so it's better for you to simply uncheck the tabs that are not used and check them only when they are used, so that it will make the interface cleaner and easier for you to use. So my default tabs are those 5 different tabs. Then going down from the command manager, we have this bar that we could call as the navigation bar. However, before checking it, we need to see the actions of the different mouse buttons. So here we have the left mouse button, which simply allows you to select any edges, for example, or lines, faces in a part. Or if you go to the left side here, we have what we call the features tree, which simply shows you how this part was created and the features that were used in this part. And so you can, with a left click, select the different features that are used when creating this part. Then there is also the right mouse click, which depending on where you click will give you different menus. So if you click in empty space, it will give you commands that are more related to navigation and the view of your part, such as zoom to fit, zoom to area, or view orientation. And we will see them since they are also available in the navigation bar. However, if, for example, you right click on a surface of the part, you will have different options that are related to what you right click on, such as common commands, such as like the chamfer and fillets, instead of going to the features tab and going to fillets to create the chamfer, which could save you time, and other features that are related to the part that you selected, such as the face in this case, or the line in this case, such as a midpoint, which is a property of a line, but it's not available in a face. Also, we could right-click on different features on the features tree, and we again will get different options. And over time and during this course, we will be seeing those different options, and we'll seeing what are their functionalities. So another thing is that if you left-click your mouse button and drag, you will have this box for selection. And there is some distinction that you need to know is that, as you can see here, I can create 2 different rectangles. If I drag from the top left and go to the bottom right, I'll be creating a blue rectangular box, which simply chooses anything that is completely covered inside this box, as you can see this edge in here. However, if we go from the top right and we go down to the bottom left, we'll be creating this green box, which selects anything that is touching the box, even if it is not fully covered. So we can see here that only what is in, for example, in this SolidWorks, we can see that only the letters that are fully covered, the S, O, L, and I, are selected. But here, even if, for example, some of the parts are selected, when the green box, then anything that is even partially selected will be selected. And then going back now to the third and last mouse button, which is the scroll wheel or the middle mouse button. So with the scroll wheel, what you can do is that you can zoom in and out. And if you check, the zooming will be focusing on where the cursor is. So if, for example, I move the cursor to the middle here and I zoom in by moving the scroll wheel, SolidWorks will try to zoom in into where the mouse is. So if I move my mouse to a different spot, then the zooming will try to focus on where the cursor is. Again, with the scroll wheel, you could click it and then move the mouse to change the view of the part. And using again the click, but this time you could also add with a control or shift. So if you press the control button and hold it and then click on the middle mouse click or the scroll wheel, you could move the part. Or if you click on the shift and hold it and middle mouse click and move your mouse, you could zoom in and out without that property when you are scrolling, where the SolidWorks will try to zoom in to where your mouse is. And from here, those are the main buttons of the mouse, and we will be going to the navigation bar on SolidWorks at the top. So we have zoom to fit. So if, for example, we pan and we zoom out by clicking zoom to fit, SolidWorks will change the view so that the part will take the full screen and it will be the center of the screen. So again, if we move somewhere else and we zoom in or out, we click zoom to fit and we'll have the part in the center of the screen. And then the next option is zoom to area, which, as it says, it simply zooms to the area that we select, and zoom to fit returns us back. Then we have here the previous preview, which simply shows the views that you used, or you could use Control Shift Z to again go back to the views that you used before. After that, we have here a section view, which we will not go into details in this introduction, but later when we are creating some different parts, we will be checking it. But this mainly does, it shows a preview of the part as if we cut it. So it shows the different features of the part when we cut it, and we can see the part inside. After that, we have here the dynamic annotations, which simply, when selected, will allow us to see the dimensions of the part when we are perpendicular to the view. So if, for example, we are normal to the top view or perpendicular to the top view, what will happen is that any dimensions that are used when creating this view will be available when we select the dynamic annotations. And then after that, we have the view orientation, which shows, as I explained in the presentation before, the different orthogonal views, like the front view, top view, or right view. We also have this, the isometric view, which shows us the default view in SolidWorks. And at the same time, we have this option, which is normal to, which is if, for example, we select this chamfer, which is at an angle, and we go to the normal view, what will happen is that we will be perpendicular and facing directly this chamfer. However, we do not need to always go back to this menu, since SolidWorks has hotkeys so that we can toggle between the different views. So if you go with Control 1, we could go to the front view, and at the bottom left, you can see the view name. If you go Control 3, we can go to the left view, 4 to the right view, 5 top view, etc. Control 6. And then we have Control 7, which goes to the isometric view. And if you select the chamfer, we could go with Control 8 to have a normal view or perpendicular view to the face that we selected. So again, Control 7 to the isometric view. We have then the next one, which is the display styles, which shows how the part is shown in SolidWorks. So most of the time when working in SolidWorks, we will be using the shaded with edges, which is what we see here, but there is shaded only without the black edges, which is sort of more realistic. Then we have simple lines, which shows the edges that are visible when we are viewing our part. We could also have solid lines with hidden lines. So as I explained in the 2D drawings, any edges that are not directly visible in here are shown with dashed lines. So as we can see here, at the back edge is not visible from this view, but to show that there is an edge at that end, we show it as a dashed line. After that, we have wireframe, which will simply show all the different edges and lines in the model. So again, as I said, most of the time we'll be staying with the default shaded with edges view. And to the next of it, we have this eye icon, which simply controls what are shown and hidden. So we will not be working a lot with it, but with this, you can show, for example, the different principal planes, like the top, front, and right plane, or you could have showed the origin. However, if, for example, any of those are like bothering you or you are not using them, you could hide anything from this eye menu. And after that, we have the edit appearance, which will be later when we are at the end of the course, when we are creating the different rendering and animations. After that, we have the scenes, which control the background of SolidWorks. And it shows the different backgrounds and scenes that can be applied to the part, and this affects the different lighting and shading of the part. So how the light reflects and how the part shows. So we will be now having like the default scene. And finally, we have this, which shows the different styles that or the different details for showing the part, like a perspective view, or like to have a more cartoony, a cartoon view, or you could deselect, for example, the shaded or ambient occlusion, which shows the different shadows of the part. If, for example, you have holes in your part or some slots, those will be shown with shadows so that they can be more realistic. And so this will be the basics of SolidWorks. So we will be most of the time working here on this main window. And also we will have later we'll be checking some of those, which is a toolbox, which we will use in the assembly part of in the assembly section of the course. And here we can see different tabs that include the motion study, which we'll be using again in the animations. So this is where we'll be creating our animations at the end of the course for different assemblies. And so another thing is that an important part is the bottom right, which shows the different units that we are using. Most of the time here in this course, we'll be using millimeters, but you could also go to inch, pound, and second if you are working with the English customer units. And finally, we have here the settings and document properties that we'll be later seeing in the course, in the customization part of the course, to see how we can customize SolidWorks to as how we want to use. And with this, like, we are done with the first introduction class. And if you have any questions, you can ask me so that I can answer you.